Take a moment to look at this handwritten digit. It's clearly a 3, right? Your brain effortlessly recognizes it, even with its unique quirks. But what does it mean for a computer to recognize this digit? How does a machine, which only understands numbers, interpret these squiggly lines as a specific numerical value? This isn't just a parlor trick, it's the fundamental capability driving the AI revolution. Understanding this core mechanism is crucial, especially when we talk about the Q2 earnings of major AI companies. Their valuations, their growth, and their future depend on their ability to build and deploy systems that can perform tasks like this, but on a massive scale. From medical imaging analysis to fraud detection in finance, the underlying principles are surprisingly similar. Today, we're going to peel back the layers and build an intuitive understanding of how a computer learns to see and classify something as simple, yet profound, as our handwritten 3. Let's start with the absolute basics. A computer doesn't see an image like we do. It sees a grid of numbers. Imagine our handwritten 3 is drawn on a tiny 28 by 28 pixel canvas. Each one of these tiny squares, a pixel, holds a numerical value representing its brightness. If it's completely black, it might be a 0. If it's completely white, it might be a 1. And shades of gray fall somewhere in between. So, our 28 by 28 image becomes a list of 784 numbers. This long list, or NLT, span style equals color blue, NGT, vector NLT/span NGT, is the computer's raw input. It's just a sequence of values, like a very long shopping list. Now, how do we get from this list of numbers to the confident declaration, "That's a 3"? We need a way to process these numbers, to find patterns that distinguish a 3 from an 8 or a 7. This is where the concept of NLT, span style equals color yellow, NGT, neuron NLT/span NGT, comes in, inspired by biology, but simply